Today we're summarizing data, and we're going to be looking more at the median range and IQR, which is often represented all in a box plot. So we're looking at box plots. So what we have to remember is when we have our data, if you listed your data in order from say lowest to highest, the middle mark would be the median. Okay, so here underneath I've written the median is located at. So here's where we're going to write that rule that I keep saying to you we've been doing. So it's n plus 1 divided by 2. So that's where position, that's where it can be found. Yeah, and remember n equals the total number of data. Yeah. Okay, so you might write that in there. So the range is quite easy. The range is always the largest minus the smallest, and it is an outlier. You do include outliers in the range. Why we don't use the range sometimes is because of those outliers, and we might use the interquartile range for that instead. So interquartile range is Q3 minus Q1. So you might always also write that the IQR is also a resistant statistic, which means not affected by outliers. Yeah? Okay, and what it says here, it shows you the middle 50% of the data. So in a moment, if you have, like we'll see, if you had your data and you're sitting at Q1 and Q3, what we're saying is 50% of all the little values you collected were in between those two numbers, yeah? And then we'd have 25% are lower than the Q1 and 25% are higher than Q3. Okay, so that's how you know. All right, so we start looking at a 5-number summary, and a 5-number summary is what we call this. So we've got minimum, Q1, that M, which is actually standing for median. You might put that in there. Q3 and max. So remember on your calculator, just if you're not very familiar with this, so remember once you've got your list in, you can do menu, and you do stats and stat calc and one variable whatever, and that will produce, you'll end up with the list down there. If you scroll down, you'll see the 5-number summary written in order down on your calculator. So once you've got your list in, you can get your 5-number summary, and you can also create a box plot on your thing. So your box plot here, I'm going to draw one up. So if you're asked to draw a box plot, which you probably would in a SAC, you have to have a ruled number line. So underneath, the calculator draws one up underneath. If you have a look, can you see here? So you can always copy your calculator page once you've done it. So then we'll get a box plot. I'm just making one up here. Okay, so here's a box plot. This number out here will be my maximum. So that is your maximum. And even though it's an outlier, it's still the maximum, and this is the minimum. So this line represents Q1. This middle line will be the median, and this line equals Q3. What these little whiskers are is it's where they're the areas where the data's gone up to before. So this shows the highest data before, or the lowest data before it becomes an outlier. And we're going to have rules for outliers to show. So really anything after a particular number becomes an outlier or below a certain one. But what I want you to remember from this point, from Q3 up to the end, is 25% of the data. So it includes those outliers if you've got them. And that way would be 25% is below it. And obviously in the middle there, we have 50% of the data. So if they ask you, where does 50% of the data lie? You go find Q3 and Q1 and say between here and here. Okay, so make sure you have ruled number line and all that. I might stop it there and show you on a calculator. So just going to flick over. So before we go on to that, actually. Okay, so I just showed you then how to do it on the calculator. Sorry, I'm just zooming in for 2 secs. So what I'm talking about with showing the data, we would put like 21 there, yeah? And whatever this one was, say that was 31. Do you see what I mean? That's what I mean when right above what they are. And maybe this one, I know the outliers might be 57 or something. Just write the actual number above it as well. Okay, so... Oh, come on. Okay, so when I said there's a test for outliers, so what makes an outlier an outlier? If it becomes over a certain value, we say it's an upper outlier. If it becomes lower than a certain value, it becomes a lower outlier. And here is the test for them. So you can see down here, you have 2 formulas that you're going to use. And the upper fence is here. And you can see you're using the Q3. So you go through and you calculate this actual number. And so what it says, so in the end, it calculates a number and just say, I'm going to say it was about here. Any number bigger than that becomes an outlier. So that's how you... So what they often say in the exam is show that this is an outlier. So it means you would put the formula in and show that it is. So you need Q1 and you need Q3 to be able to calculate what that boundary is. Okay, so anything above that number will be an outlier. The first value within it will be where the whisker goes to. All right, so we've got another example here. So it's showing you what the box did there. The box plot. Now we get a box plot. Finally, we've got it all up. We can see we've got outliers, whatever. You need to describe the shape of the box plot. And just to help you so that things are all in the same spot, I've put a histogram with the box plot as well. Okay, so if you have a look, when the box plot is symmetric, so remember our histogram looked like a bell, can you see our box plot? These inner boxes are equal, so they'd be nice, these ones I'm talking about the same shape. Okay, so they look symmetric. Okay, when we have positive skewed, so remember we have all the data at the front, what you see with your box plot is a smaller box here and that tail sort of box there like that. Okay, so that's positive skewed. And then negative skewed, you see that longer tail box here and the little box. They're underneath there, but you might not be able to see that. Okay, and if you have an outlier, we've seen that. So this one down here, so we could have an outlier. It'll be a little dot up here. You can have more than one outlier. You can have 2, 3, whatever. Okay, so let's move on. Here's some exam questions we're going to do. So the weather station also records maximum temperature. The 5-number summary for the distribution of maximum temperatures for the month of February are displayed in the table below. Okay, so there are no outliers in this distribution. Use the 5-number summary above to make constructive box plot. So can you see this is what you would get on an exam? It's not too hard. You don't have to do any drawing up of the grids. So my minimum temperature is 16. So I draw a little line there. And I do Q1 is 21. So I draw a line there. Median is 25. I'm going to draw a line there. 31, like that. And maximum is 38. And that's because they told me there was no outliers. So I draw those two up, and they're my whiskers. So that's how you would do that. that's a nice, easy 1 mark. So down here, another new question. The following question, the box plot shows the distribution of 4 arm circumference in centimetres of 252 people. So up here, you would have seen this is questions 1 to 3. So although only the first one is about a box plot, you probably need it. And just to point out to you, what they're giving you there is the number of people. Okay, the percentage of these 250 people, so they're being very nice here for you in telling you, because remember percentage, we're going to say amount over total times 100, and they were very nice telling you what the total was, so you didn't even have to go up there. And it says with a 4-arm circumference of less than 30. So less than 30, can you see 30 is Q3? So remember before I said that way was 25%. So if I'm at 25%, what would all the rest of the way be? 75%. Good. So the percentage of people with 4 arm less than 30, that's pretty easy, 75. I didn't even have to calculate the percentage. That's relying on that. It's question 1, so a nice easy one it would be. The box plot display, I'm up here. The box plot displays the distribution of maximum daily temperatures for the month of May and July. It says describe the shapes of the distribution of temperatures, including outliers for July and May. All right, so you go to July. July's this guy. What type of shape do we think that is? I think that is positively skewed, yes, with outlier. So there's my answer for that. And then the next one, May, which is here. What do you reckon that one looks to you guys? Yeah, I reckon symmetric too. Symmetric with no outliers. You gotta say that. Okay, determine the value of the upper fence for July. So they want upper fence. So upper fence equals Q3 plus 1.5 times the interquartile range, which is Q3 minus Q1. So let's do that. Then they want it for July. So if I go up to July. Okay, so we're going to look up at the Q3. What is Q3?
11.
Oh, it's 11. Good. 11. And what's this one's 8?
Yeah.
Yeah? Okay, so we're going to say it is 11 plus 1.5 times 11 minus 8 and equals, what would that equal? Okay, so we get that to be 15.5. So what we're saying is anything above 15.5, which is like roughly there, would be an outlier. So that's why that other one is an outlier. Okay, using the information from the box plot, explain the maximum daily temperature is associated with the month of the year, quoting the appropriate statistics. So I just say that maximum daily temperature is associated with month of the year because the median max temp for May is higher with what's May's, I don't know, I'm going to say it's roughly 15 degrees Celsius compared to July's median, which is, I don't know, 9, yeah? So you write something like that. So you have to have that, the median difference and the change in month, yeah? That's fine. All right, so here's some more questions. So the parallel box plot shows the maximum daily temperature and minimum daily temperature in degrees for 30 days in 2017. I'm going straight down to the questions now. Use the information in the box plots to complete the following sentences. For November 2017, the interquartile range for minimum daily temperature was. So they want for minimum, that's this guy. And the interquartile would be this number minus this number. So that looks like 17 minus 12. So 17 minus 12 equals 5 degrees. Okay, the next part of the question, the medium value daily maximum, so the medium for maximum daily temperature was so many degrees higher than the median for minimum daily temperature. So let's go find those medians. So this one was 25. This one was 15. Yeah? So what is how much higher was it? 10 degrees. Yeah? 25 minus 15. 10. Okay. Next one, the number of days which the maximum daily temperature was less than the median value for minimum daily temperature. So go have a look. So the number of days that maximum daily temperature was less than the median for minimum. So here's minimum here for the median, and how many days of the maximum were less than the median. So how many were there? Yeah, there's just one outlier, isn't there? Yep. So number of days, 1. The temperature difference between minimum daily temperature and maximum daily temperature in November at this location. Oh, we haven't done this, so that's okay. I'm going to pause it there.